So, hello everyone. So today's task is the following. Voice agent with knowledge base integration. So objectives: create a voice agent that answers user queries by connecting to knowledge base. The provided knowledge base with responses strictly to limited available information. So development steps: build with modular components, use separate tools for text to speech to text, and the large language models. Integrate these components to work seamlessly together. Okay, and the second, set up the knowledge base. Use Llama Index or any open source tool with a vector database for information retrieval, and ingest data from the layer path website to serve as the primary source of trust. Okay, yeah, I think it's understandable. Let's build this. In the simple terms, it's kind of the AI voice agent that you can type your query, or you can just dictate by voice. So, and then it will do. And there is an agent that retrieves that reads the query and retrieves the results from retrieves the answers to the provided question from the database. And then basically there is another agent that will answer to this query in more human-like language, in a natural language. So we will be not using the Llama index, but we will be using the Pinecone vector database for this. It's pretty simple to use and integrate to the applications. So, and then for large language model, we will be using the OpenAI. Okay, let me write this. Steps or what we are going to use, and how I don't know. Okay, let's put it here. Oops. So we need speech to text. So if I dictate something like question, for example, let's go to layer path actually. Why not? Okay, here let's go maybe block. Let's check this actually. Interesting. Okay, this is my query: how to optimize your customer success workflows with interactive demos. And this is my query, so I'm dictating, I'm not typing and the input. So for this we will be using the built-in SDK and the web browser, like web browser speech to text. I forgot the name. Yeah, we will be using the SpeechRecognition to recognize the user query or user speech query, and convert to text or get the transcripts. This is the first thing. It's for speech to text. And then second step. Now we have the query, and now the second thing we're going to do, we need to actually use the vector database. So for example, if I let's make this like this. This is URL, and we are copying the URL from here, and then simply putting the input. and then we're getting all the content from this URL, and then we are using this as a knowledge base for agent to answer the user queries. For example, my question could be like this: how to group demos into collections for easy access. For example, this is my question, and then there's a like answer, and there's agent that retrieves the answer and responds in a more human-like and more natural language stuff. Okay. And that's for this. We're really using Firecrawl to scrape the contents from the website. It's really it's cool application, I would say. It's cool tool, Firecrawl. I usually use this for scraping the contents from the web page and crawl a lot of hundreds and thousands of pages from the websites. It's super easy and super fast. Okay, let's back. We need to okay. We need to get we need knowledge base for agent to answer user queries. So, and for this, so we simply get the website URL as input. So then we then upload then scrape it and upload to vector database. Yep. And then after that we will use OpenAI embeddings to convert the content like text into vectors, bunch of vectors. So, and then we will use AI agent, for example GPT-4o, to refactor like to respond or replay the user to the user in more natural language. Yeah. Okay. Let's make it short. And then we get the response, for example, the replay, and we convert the replay to the speech. So basically the replay basically we can hear the replay we can hear the replay or read also, why not? Oops. Okay, we got the replay, and then that's it. Okay, what tools we are going to use? Tools for scraping. Scraping. We will use Firecrawl to scrape the content, to scrape and make it ready to embed and upload to vector database. That's it. And the first Pinecone, okay, vector database Pinecone we will use Pinecone vector database to upload the vectors or metadata. Okay, and then the second thing, we got a query and user inputs. We need to get the speech from user. Second step, speech to text. For example, I dictate the question like this: how to group demos into collections for easy access, and yeah, we will transcript this. Basically, speech to text, speech recognition, SDK. Okay, simple. And the third step, we get this transcript or query and convert to embedding, and then retrieve the results from Pinecone database using the cosine similarity. So query, we got transcripts. We got transcripts or user query. Okay, we got the transcripts, then embed using OpenAI embeddings. Okay, let's see. OpenAI embedding is the same we tried while uploading the content. Knowledge base. Okay, the same steps, and then base. We got a top one. It's enough. Top one response or top one answer answer from Pinecone vector database. That's enough. Or you can also top 2 based on the use cases and the requirements. So in the 4th step, we already got the answer. Now we should refactor or make it more natural. So natural. Okay, make it natural. There will be AI agent that will pre-process the query and answer and match answer from Pinecone vector database. Pinecone vector database. Then what will then makes it sound more natural, yep, like human like stuff. Oops. Human like stuff. Human like stuff. The fifth step, the speech to text, text to speech, TTS. So we got a final answer from AI agent. Then we will convert it to speech using ElevenLabs API. That's it. Okay, then the final step, the temp recording. So in order to play this audio, we'll temporarily save the recording in the index.db in the browser database. So to play the audio, we will saving the audio replay in a index.db kind of browser database local. It's totally temporary, so we will delete the audio after it's played. That's it. These are the steps we are going to. These are the steps to build this AI voice agent. So Okay, let's start. The very first step is scraping the content. The first thing, go to firecrawl.dev, create an account and get your API key. And then create Next.js application. If you don't know how to create Next.js application, it's really simple.
Hey, what up everyone? Today I'm going to talk about Notlink.
How I built open source fastest URL shortener ever with Rust. Because the frontend is powered by NextJS and the Typescript. So you can easily understand how to create Next.js application from scratch. There is everything is given. Yeah. We will skip this step for now and then let's scrape API. For example, scraping. It can be like this URL. We can get URL like this, or we can get URL even like this. It could be even like block and separate thing. So URL could be different for knowledge base. So the idea here is to save this in a markdown file in it as a last. For example, if user inputs this URL, we will save it in the markdown file block.md. If user input URL is like this, separate tutorial or a demo, we will be saving the same as the tutorial name, interactive demo for customer success .md or demo. Okay, this is a post request while we firstly check for example, here we are just checking for resource folder. This is a separate folder where everything will be saved. For now it's temporary, but in the future we can for example in the future or further steps, we consider to upload the file to some date to some blob or I don't know how to say. For example, S3 areas, Amazon Web Service S3 or Theos upload thing. Yeah. Okay, for now it's saved on a local folder, and then we are getting the URL from post request body, and we are just validating. And then for each URL we are generating the names using the same logic I just mentioned here, and then just joining the resource folder with the file name. So we know the file path, exact file path where file is located for further steps. And then we will scrape the content using Firecrawl. Here, Firecrawl in a markdown format, because the markdown format is really simple and it's enough for us to convert to vector and then upload to Pinecone database. So we scrape the content and save it in the resource directory. For example, here resources with a name, and just we return the directory and the files, list of files, and skip it files. For example, if you already scrape it, we don't have to scrape again and again. That's it. So that's all about scraping. And the next step, vector database. So we have content and now we should upload here in the upsert. let's go to routes. Here, this is also post request. There's a file path, the exact path, where is the file is located, and the index name, where we are going to save all the contents of this file. The first thing, we will generate the simple file ID using the string helper function, for example here, and then we will be proceeding with markdown file. We will pass the file path, file ID, and the index name. So here we go. Firstly, we will read the contents from the file, and then in the second step, pass the markdown into tokens, and then group the tokens into chunks based on the headings and etc. stuff, this function. And the fourth step, we will be splitting the large chunks to respect token limits. For example, the max worth per chunk is 500, and it's adjustable based on the model you are using. For example, you are using the OpenAI, so the token limit, it's around 8,192 tokens for specifically for this text embeddings small model. So also some function that will do this, that will split the large tokens and then embed using OpenAI model. And the next step, we have embedded and we have embeddings. So now we should prepare the vectors to upload to Pinecone database. For this, we will be needing ID, values, which are the vectors, and the metadata. Here, we just initialize the Pinecone client, and then list all the existing indexes. If there is an index that we need, that we passed from here, index name, we will simply skip this step and upload all the contents. Otherwise, we will create this index and then we will upload. Basically, that's it with uploading stuff in the Pinecone database. And next thing, speech recognition. So while I'm dictating, we should transcript. We will be using this transcription to query. So for this, we will be using the speech recognition, the browser component, create a recognition. And so basically there is two buttons, start recording and the stop recording. On start recording, we'll be starting recording and get audio, the speech and transcript on the go. And on click stop recording, we will stop and save the transcript and the state. We got the transcript and send the transcript to parent component that holds audio recorder, which is in our case the page, the main website. So, and the searching, the query, we got the query, transcripts, and get the answer from the Pinecone database. For this, we have another endpoint query folder, this post request. And the request body, we got the query and the index name. And then we query the database, vector database. Firstly, we will convert the query into embeddings, and then using the cosine similarity, we get the top one query answer from vector database. And then finally some extraction of text content, actual text content from the matched metadata. For example, we got a matching text, and then before outputting the final answer, we should refactor using the AI agent. There is another function for this. For example, AI agent, and we have a system prompt, the separate system prompt. Exactly for this, the refactor is more human-like. For example, this. The first step, make it natural. So the AI agent will process the query and makes it more sound like natural, human-like stuff. The first thing, the initialize OpenAI, and then get the search results, pass the query, and make a request. After that, we got a answer from agent, and then simply return this. Here we got the answer, and then also return from API, and that's it. And the fifth step, text to speech. We got the answer. Now we should convert to speech so the user could hear it. So here another API endpoint for this, text to speech. This is also post request. We'll passing the text as the body and the body request, and then using the ElevenLabs API, we are converting the text to speech. You can also play around with parameters, and you can also try with different ElevenLabs voice IDs, for example, also. Yeah. So after this, we got the audio response as the blob, and then return this from blob to array buffer, and then simply return this here. So in the sixth step, we have audio recording. Now we should temporarily save it and then play instantly, and then delete it after audio played. So let's go over the main page here. For this, we are using the IndexedDB. It's here. Save and play audio. We got the blob, the response from ElevenLabs, save in the database temporarily, and then create a temporary URL and play it instantly. After playing, we are deleting the audio because we don't need this anymore. So, and that's it. So let me talk about a little bit about UI. For this, it's better to run. Why not? Run dev. So now it's running. Let's open it up. Super simple UI. We can refactor and make it more look better. You can try that. Yeah, of course. Okay, the logic is simple. Firstly, you should enter the URL. Okay, let's take this, and then let's put it here. Now click proceed. It will scrape the contents and then upload to Pinecone database. If there is no index, it will create an index in the Pinecone database and then upload all the contents. Firstly embed and then upload. Yep. Here it's upserting the content. The scraping is ended. Now it's upserting the contents to Pinecone database. Let's wait a little bit. So that's it. It's uploaded. Now we can ask the questions and then agent will answer based on knowledge base that we just provided. Let's try this stuff. Group demos into collections for easy access. So okay, I see the Brave issue. Hello. Issue with Brave browser. Okay, let's input actually group demos. How to group demos into collections. For example, how to group demos into collections and send the query. Now it's processing the query and firstly embedding the query and the vectors, and then matching from Pinecone database, the knowledge base, and then got the answer, top one answer, and then process to AI agent, and then AI agent will.
To group demos into collections, you can create bite-sized tours that consist of a maximum of 5 to 6 steps each. This approach caters to declining attention spans and makes the demos more engaging. Once you have these shorter demos prepared, you can organize them into a collection or playlist for easy access. This way, users can navigate through the demos more efficiently without feeling overwhelmed by long presentations. For more detailed insights, you can read the full article on LayerPath's blog about creating playlists for demos. I will leave the link below.
Yeah, basically that's it. You can play around this because code is open source. It's under my GitHub repository, AI voice agent, and then you can clone this and play around this. You can try with Chrome browser, and then try recording, audio record. There's some privacy issues with Brave browser, that's how I could not record this. So, but you can play around this. Yeah, basically that's it for this AI voice agent. I hope at least we learned to use different tools. For example, Firecrawl for scraping, Pinecone database for vector database, speech recognition, the browser stuff, the fast for recognizing the speech, embeddings, OpenAI embeddings, GPT-4o model, AI agent to refactor or make it human-like, text. For example, as you heard, it said like you can learn more about this and the blog, like blog under this tutorial or stuff, because we refactored. Otherwise, it would say like you can learn more about slayerpress.com/blog/interactive demos blah blah blah. But there's AI agent that will refactor this. And then we save this temporary recording into indexeddb, the browser local database, and then play it instantly and then delete it. Super easy and cool stuff to play around, to learn new tools, how to use tools. Yeah. See ya.